Welcome everyone to this webinar with the title Certainty Shapes Good Strategy. It's a forward-looking heading, but bearing in mind the previous, let's say, 8 months, it could have been uncertainty shapes inefficient strategies or ad hoc or expediting strategies. This webinar is a co-webinar between Plan, Oracle, Flo Group, and Jönköping's University. And once again, I warmly welcome everyone to this 1.5 hour roughly. So my name is Lindau. I'm working at Oracle as a senior executive advisor in supply chain management in the Nordics. And our speakers today will be Professor Joakim Wikner, who is well known within the Plan community, and he's a professor at Jönköping's University. And we have Eric Orillat. Well, excuse my pronunciation, but he's working at Flo Group and he's working as a solution architect. And well, I think it's time, Joakim, to give the stage to you, please.
Well, thank you very much. I noticed I had some Swedish vocabulary in one of my slides here, so I'm quickly changing that. But
while you're doing that, Joakim, can I just add to everyone that this webinar is being recorded and it will be held in English. So that's just my last statement. Welcome, Joakim.
Thank you very much. So my name is Joakim Wikner, and I'm a professor in Jönköping University in well, logistics, you could say, and mainly logistics related to manufacturing and manufacturing planning and control. I'm also doing some part of my time at Linköping University, and then only for, oops, I'm a problem getting in presentation mode here. There it was. So I need to. So this is a picture of Jönköping University, and I'm located in Sweden then, at the south end of Vättern, in the southern parts of Sweden. And this is the view from the south of Vättern. So I'm sitting presently actually in the yellow building here on the right. So I talked to Roger about this, and to provide with some kind of generic picture of supply chain network modeling and some aspects that are interesting to consider. So I'm covering maybe about 15 minutes here, and then there's some time for Q&A after that. Looking at this sort of abstract, what it says, there are some keywords there that are quite interesting. And it's considering, for instance, what is the true nature of these networks. I would like to share with you something about a number of system perspectives that we can have, and then also to use a simple example to illustrate that. And when it comes to that they're often not visible to many, I would like to quickly have a look at a way of modeling flows that can be quite useful in this. And the last keyword I find interesting here is what is really customer service? And in particular then, how can we use a more adaptive approach to actually running these networks? So this is the three areas I would starting with the first one, to just make it quite, it's like the way I view any kind of modeling of enterprises or supply chains is basically that it's a very complicated matter, and I think it's good to try to approach this as we approach architects, for instance, approach buildings, etc. That you make an abstraction and you look at sort of certain aspects of this, and it could be, as an architect, looking at it from the flow of people in the buildings or the electrical system in the building, etc. And here I would say that we have the physical perspective. That is a lot about the actual value-adding transformation taking place. That is kind of the baseline. I think that this is also that where we have most of the focus when we do supply chain modeling in most cases. Then there is some kind of legal or financial perspective, which is also actually, as I see it, mainly just a reflection of what is going on in the system. So that is kind of the baseline. And I think sometimes what we forget about is that we're actually going to control this flow also. So there's some kind of fundamental logical perspective in this. So there is, if we look at the system or enterprise or supply chain, there's certain aspects that we could consider, not maybe all at once, but focus on one of them at a time. Then there's also the matter of, there is some kind of building blocks in this, how we create these parts of the network, and it's also a matter of how to use these building blocks. I would like to just give you a quick example to see sort of how it could be used or interpreted. This is just a simple system where you get orders and you deliver from stock in this case. And consider then this system and looking at it from a legal perspective, and then let's focus on just one inventory point or one stock point. We really get into questions sort of who owns this inventory. And it could, for instance, be consignment inventory where the supplier owns the inventory. But it's focusing on the ownership and the business transactions in this and how it affects the system. The physical perspective considers more, where is this inventory? It's a traditional supply chain issue. Is it a central distribution location, or is it as a factory in a warehouse, or where is it? In this case, it could be, for instance, raw materials in an on-site inventory or something. And then if we separate the logical or the control perspective, we get into the issues like who actually controls the inventory. Is it a vendor managed inventory? Are they using a min-max system, or is it some kind of order point system? So by my view of this is like to see kind of what is the true nature. It's good to focus on certain aspects at a time and not mix everything up at the same time. But in this, as I said, the physical perspective is really the baseline. And then we add as a layer on top of that, the legal perspective. And after that, you can see the logical perspective as the way you would like to control this. And many times, when you look at it from a logical perspective, and especially from a customer perspective, what is key for the customers, for instance, is not exactly what you do in the supply chain. It's more the time it takes and potentially the cost of it. And so those are key issues, and that is a huge abstraction from looking at if we have like as logisticians, we focus a lot on exactly what we're doing to make the flow efficient. But from an outside perspective, it could be the lead time as such. That is the key point. So that is one thing. Digging into then how to actually model such flows, and to a large extent here focusing on from a kind of logical perspective or controls perspective, how to model a supply chain. And we need to, of course, to focus on the stuff that is sort of the physical supply chain. But then looking at this is a very simple case, like a process industry producing. A process industry is here defined as something, a kind of business that have certain parts of their flow is related to continuous objects, stuff that we can't count. We measure them in weights or volumes or something, but they produce it continuously, usually on speculation, meaning to forecast. Then they package it, in this case, into some kind of generic containers of different sizes, and later they can be customized by adding labels or something at the end. So this is the kind of logic. And looking at this from 3 perspectives, we could see what is actually driving the flow in this. This is an important part of modeling. Is it custom orders that drive the flows, or is it sort of the schedules or the forecast? The other part is, are we dealing with the flowing things, which are completely different to handle compared to countable things? When they're packaged, they can usually be stored just in a storage warehouse or something. But in case we have the fluid stuff, we need to put it in specific containers. And the last part is, of course, are we controlling this? Well, in the objective, the CEO is representing continuous objects, which is flowing things, and the discrete object, DO, is more countable things, like when we have packaged them because they're 10 pieces or whatever. And for the flow driver, SD stands for forecast driven or speculation driven, and CD for customer driven or commitment driven. When we look at the control mode, then we can see we have things that happens once, one-time mode. We can have them batch-wise, intermittent mode, IM, or we can have them continuously, like a rate-based flow. So looking at this on the top left here, if we look at the blocks, which blocks are they actually using? So they're using that one. So this one is continuous. It's rate-based, the way they control it, since it's the continuous production. And it's continuous objects, so it's behind there. And it's also speculation, it's all on forecasts. So that is that block. The next part, then there's a transition into being batch-wise production because they package it. Still on speculation, but now when they package it, shifts from being continuous to discrete object. And then at the end, it's actually customized for a specific custom order. If we put this as a flow structure, then we can see that actually this flow from a control logic perspective consists of 3 distinct parts that are require different kinds of planning and control mode here. So this is the way of modeling the flow from a more control logic perspective. So moving on to the last part here. If we had the true nature, we look at different perspectives, and then we can see that when we look at the control perspective, when we do the flow modeling, then we get an abstraction of the flow that doesn't concern really the details of the flow from a physical perspective, but more what are the key points when we look at it from a control perspective. And then how do we provide customer service in this? And I think this is an area where we use a lot of measurements in different parts, but it's not always sure that the measurements we use and the measurements we use to control the sort of the flow is also what is really appreciated by the customers. So putting it is a simple, this is kind of a control problem really from control theory. This is the delivery system. We have some kind of value adding flow, the black box. We have a flow control that we apply to actually run this. And then we measure and we look at this, for instance, how much inventory do we have? What is the status of different orders? And then we adapt that and we give new orders to the value adding system. And all this is based on demand from the right side to actually making it possible for us to provide deliveries. The value adding flow could consist of manufacturing, distribution, even retailing, everything that concerns that we add value to this. Looking at from a control perspective, we also include quite a few buffers here and there. And the buffers, they are really providing the customer service in terms of avoiding unexpected back orders, etc. So we have some kind of dimensioning here. It could be safety stocks, or it could be safety lead times, or it could be extra quantity order, etc. So there is a dimensioning problem here. Say it's the key thing to actually measure what we get as a customer service, or the customer service we provide, and compare that to what we actually think we were trying to achieve. Because it could be that in many cases that customers are interested in order line service, etc., but the methods we're using to set the buffers are actually based on something else. It could be a number of days. I will show an example, number of days of demand, or it could be some measure of uncertainty and standard deviations or stuff, something like that. And that would give us some kind of safety buffer, but we're not sure if it really gives the service level to the customers in the way that they appreciate. So that's why we set the buffers, and then we measure how they appreciate it, and then we get an appreciation. Do we need to adjust this? It could be in this case. We have, for instance, 4 days of demand that we want to cover. The demand is 5 pieces per day. Then actually this provides us with a safety buffer in this particular case of 20 pieces. But that when we look at the service level, for instance, on order line level, it only provides 91%. And we know that we need to consistently deliver on 95%. Then we actually need to increase this. And this way of setting parameters, then measuring what we get in the final end, and then checking that measure to see if we're in line with what we want and adapt. This is the adaptive control logic. I think this is quite often actually applied in practice, but not on a very systematic way. So having those sort of system perspectives, then identifying what are the key points here, and then having an adaptive way of looking at this, the flow logic that we're actually using at the end. I think that is a quite interesting way of approaching supply chain modeling here. So starting with that, basically added system perspectives to sort of have focus on one sort of perspective at a time to make clear that we actually make a good system, create a good system from the different perspectives. Sometimes we can make a really good physical flow and provide a really good sort of control logic to it. But when we add the financial perspective, we need to do some adaptations to this. And that means also that we know what kind of adoptions we're doing to the sort of ideal flow we would like to have. And that makes it possible to also see how could we maybe change this financial aspect to actually better support the flow logic that we want to preserve. So that I also wanted to give you just a quick idea of how you can sort of make an abstraction of a quite complex flow to identify some key control points here that actually we have a shift from one. When we sort of have the flow from the left to the right here, in this box, we have a certain preconditions that we work to. We have forecast, we're dealing with continuous objects, and we're dealing on a rate-based setup. But here we get a shift from the continuous mode to the intermittent mode, the batch mode. And how do we do that? So the key things here are really the interfaces between these blocks. And then finally, I would like to promote an explicit adaptive approach to actually controlling the flow. And even if we can't use control logic that actually sort of implements the customer service we would like, then we need to measure the customer service to actually see what we're getting from this. So, oh, sorry for that. I think I'm finished there. So that was a quick overview of supply chain network modeling.
Thank you, Joakim. I can see on my chat that there aren't any questions, but I have some questions to you, Joakim. If we consider a global network with multiple suppliers in the range of many hundreds, maybe thousands, you have thousands of lanes, you have a number of factories, you have a kind of network of factories, and then you have customers in different locations. If I would sit in a company like that, and then I look at all the details, the complexity added, and then I adapt your presentation, how do I start with this? Because it feels like an infinite kind of work burden to start modeling my super global complex network. Do you have any suggestions? How do you start to make the big complex quite simple, maybe not the most detailed decision information, but to start somewhere?
I think isn't it, as in most cases, when we do modeling of really complex things, that we need to see if we can sort of disintegrate it in some way into some subparts that we can actually focus on. It's the same, I would say, as you do with value stream mapping or something. You focus on a specific value stream, or you focus on a product family and what suppliers are involved in that flow, and to start to set up that. Because if you have a completely integrated control system for everything involving all this, then you probably have a huge complexity in the way you're running it too. And my guess is that you have split it into a number of sub-supply chains that are actually controlled in different ways. And I would probably start with the ones that I have most comfort in dealing with. It's like the classic low-hanging fruit, and start looking at that and to see how does it work, and especially this, where do I have these key control points in this flow, and not maybe looking at the key control points in terms of where it provides me with problems, but maybe also key control points when you're looking at it from the outside. What is it really that matters for me in certain parts of this, and then design. So in some parts where you have very much on focus on customer orders, probably lead times, etc., are very critical, the short lead times. But in other parts, you would probably have other sort of things that are mattered, could be cost driven to a huge extent. Then you would focus on how do I make this more cost efficient, and time is not such a critical aspect. So it's probably to some extent a case by case thing, but to find subparts of the more complex structures that we can actually understand in a better way is probably the best start, as far as I understand. Maybe there are some other ideas out there, but
and then I have a very quick one before I go to one of the questions on the chat. If you start big and simple just to frame a certain, call it problem area, is it possible to add on to that one? Is it possible to make the simple and quite easy one much more detailed, and you start like iterating your network in that case?
Yeah, I guess you could look at that in many ways, but that's to some extent what I'm thinking about with this part. If you actually start by setting up what is the control logic I would like to have on this, then you could sort of ignore some parts that are maybe causing a lot of present problems, but then you get an idea, this is what I would like to achieve. And then you can actually add the layers to see these are some preconditions that I must consider. But then you also know, where do I need to focus my improvement actions here to actually reach that sort of more or less optimal control model I would like to have in this. So in many cases, I think the design is starting with a physical perspective, but maybe it would be a good idea to set up from a control perspective, planning and control perspective, what would I like this to look like, and where would I like to have my key control points in this? And then can I change the physical on a longer time horizon to actually fit this in a better way? That is maybe one way of using this to actually attack complex problems.
Okay, Joakim. And then we have a question from one of the listeners. And with the C19 situation, there has been a shift from manufacturing far away or from China and closer to the consumer. Have you seen anything of this, or will this reshaping the supply chains in the future to, I would express it as try to reduce the complexity of the global supply chain and work more with shorter lead times, which are not as sensitive as long global complex lead times? Do you have any?
I probably don't know very much more than you know about this, but if I look at it from the research side, there's a lot of interest in how will this really affect the supply chains. And it's also interesting from a logistics perspective, because from when I say logistics, material flow in general, we're very interested in lead times to a large extent. But that lead times and the robustness of lead times, etc., have maybe had received less interest than the cost aspect of it, and also then costs that are not covering all the on costs that we get from actually locating far away. So there will probably be much more interest in lead times, and I see probably a great potential for. And I think that's a challenge for logistics people to actually translate lead times to financial numbers, to be able to express what is the financial impact of this. We can see that if you do changes in the supply chain, we get complexity in terms of when we're trying to run this and control this, but it's not always easy to translate to costs. I'm not sure that the COVID-19 is sort of making it easier to do that analysis, but I think you get more arguments for why you can get some negative aspects from sort of unexpected events on complex, long supply chains. And the closer they are, the parts, usually they're easier to control also.
So now is actually the time to move the supplier base closer to where the production is and where the customer is, because everyone is bearing the C19 in mind, and now it might be that the business case or the quantitative parts of the business case is much easier understood by decision makers.
Yeah.
If there aren't any more questions on the chat, then I will thank you, Joakim, for a very good presentation and a very good discussion. And I will hand over to our second speaker today, which is Eric from Flo Group. And the title of Eric's presentation is Identify Hidden Benefits Within Your Logistics Network. So if we try to do the technical change of the control, and then I say, Eric, the stage is yours.
Yep. Thank you, Roger. I'll quickly share my screen. Okay. All right. So you should see a picture of a bridge now. So, so thank you for having us today. As you said, my name is Eric Orillat. I'm a solution architect with Flo Group. And today, I'm going to tell you about Flo IQ, which is a service that Flo has offered, as packaged, that's revolving around logistics network modeling, and which is a module of Oracle transportation management. But before we dive into things, I'd like to briefly tell you about Flo, so that you know who we are. So we are a global consultancy company, and we are specializing in supply chain solutions. We are an Oracle Gold partner, and we have been for many years, and a leading implementer of Oracle Logistics Cloud, which includes Oracle Transportation Management, Global Trade Management, and also WMS for warehousing. So we have also strategic partnerships with technology providers in the areas of advanced planning, carrier connectivity, visibility, and among others. And we have also developed our own suite of applications for master data and configuration management to accelerate implementations. So I'll tell you a bit more about this because it's an integral part of the solution here. So as I said, we're a global company. So even though we are headquartered in Europe and we focus primarily on the EMEA market, we're also creating global solutions for our customers, and we are supporting them around the world when we accompany them in their deployments. So the map here is just showing a small sample of the customers of our client base. and where we've been with them while implementing mainly OTM, but also other applications. We have the largest pool of OTM consultants in the world, and we also have an office in Pune, India, which allows us to offer also lower cost offshore solutions, not only for implementation, but we also for support services, such as AMS, so help desk services, but also testing services like automated testing and regression testing and testing of new OTM releases as they come out, and also master data management. So we have many very experienced consultants, some with over one decade, sometimes even 2 decades of experience on OTM. So that was for Flo. And so I've mentioned OTM a few times. So just to make sure that everyone is aware of what OTM is and what it does, I'll quickly present it. So this OTM is one of Oracle's logistics cloud applications, and it's a TMS which allows the management of all transportation activities throughout the supply chain. So the normal end-to-end flow is for OTM to receive orders, usually from an external systems like an ERP, and OTM will first plan those orders into shipments. So that involves routing orders through the network in an optimal way, taking advantage of consolidation opportunities and selecting the best carriers in order to optimize costs, while also respecting all of the constraints that we can put on the network. So once those shipments are built, they are tendered, booked with the carriers, and OTM can also be used to manage the own fleets. So during the lifetime of a shipment, OTM is also used to monitor the shipments by centralizing and displaying visibility information. That visibility can come from carriers themselves, or it can come from a visibility service, such as P44 for guys, for example. And finally, with the freight billing and freight payment and billings module, OTM can automate the settlements of processes for all costs, including surcharges, discounts, and extra costs. So it's a complete order-to-cash system, which is also supported, as we can see, as with a global logistics data model. So that includes master data such as items, locations, transport rates, the transportation networks, itineraries, carriers, and so on. So now that we've seen what OTM is, I'm going to tell you a little bit about Flo IQ. So Flo IQ is a service that we propose, which is based around LNM, so logistics network modeling. More on that in a minute. And it is meant to identify hidden benefits and sources of optimization within transportation networks for our clients. So what we do is that we run a 6 weeks exercise, during which time we run a set of what-if scenarios. So the nature of the scenarios will depend on the nature of the clients and where they think optimizations might lie. So for this 6-week study, we use the operational transport network data of the customer. So we use the real network and the real orders from the customer to run simulations on them and to to identify some quick wins, opportunities, and especially also quantify those potential savings. And that also we also provide dashboards and metrics to visualize those potential savings as well. So Flo IQ is made up of several components. So the first one is Oracle Logistics Network Modeling, which is one module of Oracle Transportation Management. This is a separately licensable module of OTM. And as I said, it allows to run what-if scenarios, as we will see. And we associate it quite uniquely with our own product, which is Evolve Data Loader, which is part of Flo's suite of applications that have been developed over the last few years internally by Flo. And they are designed to support and accelerate OTM implementations. So Evolve Data Loader itself, as the name suggests, makes it easy and fast to extract any data from a system, transform it as required into the native OTM format, and load it into OTM environments. So with this simplified manner of loading data, we are able to quickly replicate onto our own Flo instance of OTM the characteristics of our clients' transport network, including all the locations, the rates, the lanes, the carriers, everything that's required to run those simulations, and also to import orders, to run simulations on them, and the shipments as they were planned in either the legacy TMS or in OTM, or planned in real life if the client doesn't have a TMS yet. And finally, the last secret ingredient is our logistics intelligence, which is relying heavily on the experience of our consultants and our common experience to identify where we think savings may lie, and to quantify those savings and advise on the best way to achieve those savings. So that's the components of Flo IQ. So we'll start by looking at LNM first and see how it's being used along with Evolve to deliver those benefits. So LNM is really about what-if questions. So if you've ever wondered what happens if I change my rates during a tender, for example, if the rates are going up, or what if I allow multi-stop, or what if I reduce the number of rate structure? What would be the impact on my network? Could be what if I exchange a carrier because there may be quality issues with the carrier? What would be the cost impact of that? Or if we push a bit further, what if I move my warehouse? Or what if I add a warehouse to the network? Or maybe I want to add new customers, or my main supplier is changing locations. So those kind of questions can have a major impact on the network and on the costs of running that network. And what Flo IQ does is to allow to model these scenarios before the changes are made and see the impact of the changes before they are made, and therefore to secure that the right decision is being made. So how does LNM do that? In a typical OTM implementation, so LNM will be present alongside OTM with the 5 end-to-end processes that we've seen before. And LNM will run simulations by using real-world data. So all the orders and items, the transportation network, the carriers, the rates, the equipment, the locations, all of that are the real data that is already available in the system. So if you're running OTM, all of this will be set up, and that's what the system will be using to plan real orders into shipments that will be actually executed later on. But on top of that, LNM can provide the ability to make changes to model various scenarios. So data rules can, with data rules, you can change the existing setup. So, for example, you can deactivate some carriers or activate some carriers or the associated rates. You can change some order release properties. You can add an itinerary or a new network. You can change the opening times. So what happens if my locations are open longer? Is it worth the costs of staying open longer if I get a reduction in transport costs? Or what if I constrain the network, if I add capacity limits because my carrier has said that they cannot provide more than 10 shipments a day for a particular site? What would be the impact of that? Or what if I'm in a contract negotiation and I can promise a new carrier 50% of the volume on a lane? How does this extra constraint, what effect does it have on the costs as well? So that's the data changes, the data rules, sorry. And the data changes are changes that we make to the transactional objects. So that could be adding orders which were not there before, or to change the current set of orders. So what if I put a higher priority on some orders? Does that improve my service levels, for example, because higher priority orders are delivered first? So that's the kind of questions that LNM can run scenarios on. And those scenarios are run in memory. So all the shipments that are generated by LNM are not committed alongside the real shipments that are planned in the TMS. Therefore, each time a scenario is run to test an idea, LNM will take the orders, plan them, and create those shipments, but it's a reduced version of, they are not full shipments, they are just have the shipment characteristics, and they do not mix with the real shipments. And the important thing to note is that LNM is using the exact same planning and routing engine that OTM is using to plan orders into shipments that are executed. So you get an exact picture of what OTM, how OTM would plan these orders if those parameters were different. So using the same data, the same transportation network, but you're also using the exact same routing and planning algorithm. Therefore, those simulations can be run in any system. So in a development system or test, or even in a production environment, because they do not mix and they are kept separate. So you can run these scenarios on actual production orders without having to generate huge amounts of data, because the data is already there, it's the real data. And LNM also includes a set of pre-built dashboards and operational metrics to be able to visualize the results of those scenarios. But so now we've seen that what LNM can do within the context of an OTM implementation, and we've seen that we can simulate those changes on different levels. So that's already pretty cool. But if we want to go one step further and ask other what-if questions, so well, it's all well and good, but I'm not an OTM customer at the moment, so I don't have access to LM. Or what if I don't even have a TMS? Maybe I'm planning all my my shipments using an ERP, or I'm just sending my orders to my my LSP. Or what if I just don't know where to start because maybe it's time consuming, or I don't have the competence internally to do that. That's where Flo IQ really gets really comes into play, because Flo IQ allows you to benefit from the power of LNM, as I just explained, to conduct this study using your own data, but without having to have the upfront investment into a TMS. So what's our approach? So as I said, we are conducting usually 6-week studies. That is the standard, but depending on the number of scenarios to run, that could be extended. And during those 6 weeks, we will start by collecting data, because that's obviously where everything starts. So for this, we use Evolve Data Loader, as I explained. So we have templates there that are ready to collect the data which is going to allow us to replicate, first of all, the master data to replicate your existing network. So locations, the carriers, the rates, everything that makes up the transport network, and also the transactional data in the form of orders. So we're going to pick a week, or maybe 2 weeks. If it's seasonal, for example, we can pick 2 different weeks at 2 different times of the year. And we're going to take the amount of orders that were actually planned during those 2 weeks. And we're also going to import the shipments as they were planned in real life, whether it's in OTM, TMS, or if they were planned differently. So we have those pre-built templates that allow us to very quickly collect that data and import it into our own OTM instance to run simulations on. And which is the next step. So the next step is to create a baseline scenario. This is really a simulation model that we are creating using real-world data. And once that's created, then we can run experiments to see how the changes made to the model can affect the overall cost of the logistics network. So we run that baseline scenario with the orders that we've imported, and we're making sure that the results we get at this point are exactly the same as the results, as the shipments that were planned in real life. So this is kind of a test and setting the base. The next stage is to run those modeling scenarios. So depending on where we think savings may lie, then we will define in advance a set of modeling scenarios where we will make one change at a time, run a simulation, compare that with the baseline or with the previous simulation, and see whether that change is beneficial, or if there are no savings, or if the savings are just too marginal. So we can see the impact of that change. So each scenario can be independent when we change one parameter at a time, or we can build gradually on a scenario on the baseline, and then each scenario is building gradually on the previous one. Then we compare the results. And for that, we have the standard LNM dashboards, but we have also developed our own set of dashboards and reports to supplement the standard ones. And I will show them in a minute. And these allow us to identify the improvements that that could be had. So we're focusing first on the quick win improvements that could be implemented in short run, but also on longer term and deeper changes that could be done to the network. And that's really the final step, which is, given the experience in implementing TMSs, then we can also advise our clients on implementing those changes that have been identified and quantified. So these are just a sample of some of the scenarios that we could potentially run for a study like this. So the baseline scenario, as I explained, that's our starting point. So we're testing the model at this point. And the first one would be to just let OTM run in an unconstrained manner and see what are the raw benefits of having a TMS instead of planning manually or planning in a different TMS than OTM. So this is what the job that OTM would make if it was free to plan as it wishes. Then, for example, we could also further to that add the current allocations. So, for example, add quotas on lanes, because we've promised 50-50% to the two carriers on a given lane. So see the impact that it has on the costs, and see how much this is costing. Next one could be to remove product incompatibilities so that we can load two types of products on the same vehicle. This is based on a real life scenario where products that were incompatible had to be loaded on separate vehicles, and removing those incompatibilities obviously delivered some benefits, but we intuitively know that there will be benefits, but running that scenario really can quantify how much is to be saved. Is it worth the extra hassle to mix products? Then allowing multi-stop, so whether it's multi-peak or multi-drop or both, how much savings would that deliver? And if we push further, for example, if we use our own sites as cross-docks, as consolidation or deconsolidation pools, what could be the benefit of that? Obviously, it will have a cost, but is it worth doing? So that's some of the scenarios we can run. Obviously, they must be adapted to each and every customer. So these are some of the reports that we've also added. So we've got a report that shows the overall scenarios, and so comparing between scenarios, number of shipments, transport costs, shipment consolidation, etc. Then transport insights, see the transportation characteristics and the carrier performance. Then shipment consolidation or the quota compliance. So do we comply with the quotas that we have promised the carriers, or do we not? And the rate compliance. So are we using the correct rates or not? So that also shows that conducting this study also give insight and more visibility into how the transport network operates and what can be the dynamic into the network. If you see that only changing one parameter has a massive impact, then that's something to dig further. So generally speaking, the deliverables are these baseline scenarios, the unconstrained as OTM would plan if it was free, and then a number of scenarios, each of them with represented on the dashboards with the amount of savings that could be achieved, And so this for each and every scenario, and obviously a final demo with quick win opportunities, and which could also support a TMS business case. So Flow IQ can be run on multiple levels. So at the top level, we have the strategic network review. So this could, we could foresee that taking place like 1 or 2 times a year. And that's really a set of strategic what-if scenarios to identify potential changes in the network, but fairly, well, let's say medium-term changes, because they might require opening, closing sites, or changing the operations at sites, but also maybe renegotiating rates with the carriers to allow multi-stop, or merging rates together. Then the tactical planning and performance review, which will happen quarterly or monthly, really more focused on the performance of the existing network, and whether by changing small rules we could make a difference and achieve some savings. And finally, the operational planning performance reviews are run more regularly, simply to review the actual performance against the defined rules. So have we achieved our quotas that we promised? Or if we are aiming for a fill rate of 65%, have we achieved that? That's the sort of things, and compare what actually happened with how OTM planned it, and try to understand if there is a deviation, where the deviation may be coming from. Okay, so just as a conclusion, so what are the benefits of undergoing a review with Flow IQ? The first one is to identify those benefits and the cost reduction opportunities. So using those simulations, which is and Flow IQ gives, which is very important to bear in mind, gives the ability to customers who do not have a TMS or do not have a TM, give them the opportunity to use LNM to conduct those scenarios on real-world data. And to do that, we use Evolve to accelerate the import of this real-world data and run those scenarios. So this is really having a picture of what if these orders for that week or those 2 weeks were planned using OTM. So that's the first thing, those to identify those benefits. And you also get very accurate results, because as I said, it's using real world data, master data for the transport network, but also transactional data. And the algorithm is the exact same one that is used by OTM. So it's like a try before you buy. So what job would OTM have done if I was using OTM? So that's really what it gives, the idea that it gives. And this is also supporting business decisions, because you can try a change in advance. So you can see exactly the impact of the change before you do it, and before you engage any investment in that change. You can see how much you would save, and whether the change would be beneficial or not. Is it worth the extra costs or not? And finally, to implement these identified and quantified opportunities can be implemented rapidly, because they have been identified. So it's not a guessing game and a trial and error where you change something and you actually plan for a few weeks and see whether the change was good and should be kept, or whether it should be rolled back. You know in advance which changes are going to deliver benefits. So that is also one major benefit of Flo IQ. And so depending on the complexity, so medium to large size companies will always require a full TMS, but for smaller size company, Flo IQ can be used on a regular basis to conduct a kind of health check of the network. And for those larger and more complex companies who are running a TMS and who are maybe running OTM, undergoing this exercise will also allow the identification of those benefits. So all of this drives certainty to close the loop, because you know exactly in advance the results you would get before you implement a change, and you can make really a fact-based business case for full TMS implementation, because you know what the results would be if you had a TMS, but without this investment upfront. So whether you've been an OTM customer for years, or you're thinking of changing a TMS for OTM, or even if you don't have a TMS now, you can gain insights into your transportation network and your operations, and you can identify inefficiencies, sources of improvements. You can quantify those savings in advance, and that will allow you to justify whether it's just a change or a full TMS implementation, and accelerate the implementation of those required changes because they've all been tried before. So that's all I had for today. So thank you for your attention, and back to you, Roger, if we have questions.
Good, thank you very much, Eric. And I have some questions, and we can start with the first one, and that is if you have any, call it live examples of any of those kind of exercises with the shown process, and what the effects were.
Yes, we do have some examples that I cannot directly share over here for confidentiality reasons. But yeah, we have conducted studies, and some of the examples I've used here for the scenarios, for example, are based on some real life cases, which I've just anonymized. So for example, our customer realized by the very first scenario after the baseline scenario. So once we let OTM plan the orders, as opposed to orders being planned in the ERP, just because OTM doesn't miss any orders. So everything is planned. There are no orders left behind, and there's more consolidation because OTM can make those decisions between, for example, part loads or full loads. And just because there's more consolidation, you also get better part load rates. So there was already a 2 to 3% reduction in costs just because OTM was doing the planning. On top of that, we are able to achieve I think I was gone for a few seconds. Am I back?
Yes.
Yeah, I'm back. Sorry. Yeah, I disappeared for a while. So yeah, I don't know where it cut off, but yeah, I was saying we were able to achieve up to 8% reduction overall in some cases by just having OTM plan the orders, but also, as I mentioned, having more common rate structure between sites, because they realized also that two sites that were close together were using different rates. I think it was the same carrier, but different rates, which were not compatible with each other, which were preventing multi-stops from being created between those two sites. And by just having a common rate structure, they were able to achieve additional savings by having multi-stop. And so that's a couple of examples, and also using their own sites as deconsolidation pools. That was also that also yielded some additional savings. So yeah, it works. We've tried it. Yeah. Mm-hmm.
And then I have one more question to you, Eric, and that is, how is demand in scenarios generated? Is there a kind of connection between the scenario planning coming from the integrated business planning, or is this some kind of standalone demand generation or scenario generation?
Okay. So it will depend completely on whether the client is already an OTM user or not. So if they're an OTM user, then they will have to license the LNM module, and we can run those simulations in either dev or test or production environments by taking the real orders. So those orders wouldn't have to be generated; they would be the real orders, and using the real network and the real rates. But on top of that, we define scenarios, and I don't know if there are many Photoshop users here, but the scenario is like a layer that is like a Photoshop layer that you put on top of your real data. So you don't modify the real data, because if it's production data, you obviously don't want to touch it. But this layer will, or mask if you want, or will run a scenario as if the data had been modified for real. So you can modify the orders, or pretend to modify the orders, and also the transportation network. But the real one, the underlying one, is not changed. It's only changed, simulated for the scenarios. So that would be the first use case. But as I said, FlowIQ is also providing possibly even more benefits to clients who do not have OTM. And in that case, we will export the data from a TMS or an ERP and use Evolve to speed up the import of that data. And that data will be imported into our own instance, where we will be running OTM and with LNM to run the scenarios on behalf of the customer. So either you use the data, and because you're an OTM customer and you already have your real world data, or it's fairly easy to extract, transform, and import the data into our instance, so that you can run simulations on your real data, and without having to fake massive amounts of data, which may or may not reflect the reality. Here, we take the real orders that were executed. So that's important. Yeah.
There aren't any more questions on the chat, but I have a final question, or maybe there will be another one, but we'll start with this one. I mean, if you consider all the different cases that you have been involved in, what is the major challenge that you normally face? Because it's not just a walk on the sunshine. I'm sure there are some integration or whatever. What is the major challenge that you're facing when you're running these projects?
Well, normally one of the challenges would be the effort required to import data in the first place, because then if you have to mess with Excel and CSV files, that can be a very, very time-consuming exercise. So using Evolve as an accelerator and those templates allow us to do that much more rapidly than if it wasn't there. So that's one thing. The other is to work with the customer to identify the right scenarios to run, because obviously there are 1,000 things that can be changed in the network. So you have to have some kind of you have to sit down and work out with the customer where they think that optimization and benefits may lie. And in that, we also, our experience also come into play, because we've seen dozens, if not hundreds, of implementation cycles. And we know where usually the benefits lie of implementing a TMS, or just by looking at a transportation network, there could be some obvious things that could be changed. Or it could be something that the customer has been wanting to try for years, but because it represents an investment and it's not guaranteed to work, they haven't done. But many customers have plenty of ideas or things to change in the network. So that's usually where we start. So there's, getting the data, identify the savings are the two main, or identify the scenarios to be run are the two main challenges.
And then, of course, a second one, but this is the last one, because I know people want to leave and go for breakfast, maybe some, and lunch, some others. When you're meeting up with companies, do you find that they are organized in the way that you can run your project in a nice, smooth way? And do they meet up with competence? So you have a good kind of person, group, function at the other side who can support you in your kind of broader approach to a company?
Well, I suppose it varies by from one company to the next. Obviously the company has to be willing, and there has to be a drive to improve the network. So usually we do find that companies, if the engagement kind of tends to grow after we run one or two scenarios, and they tend to realize, just by implementing a TMS, we can have, and not doing anything, not changing anything, we can save already 2 or 3%. When they see the savings that can be achieved fairly rapidly, then the engagement tends to grow. But of course, to define those scenarios, we also need to work with them. So there has to be a drive behind it. Yeah, for sure.
Good. Thank you very much, Eric. And as a conclusion, I would like to ask both Joakim and Eric, and a very, very short discussion. I mean, supply chain network modeling is nothing new. I mean, what did you say, Joakim, when we spoke? It's probably about 30, 40, 50 years old as a discipline, depending on the different details and so on and so forth.
Mm.
But still, there aren't many companies having a set up process for this. There isn't an organization. I have met some companies. I have been in the situation where I've done similar things, but it was a one-off as a project. Can you elaborate a little bit? Why isn't this a standard process as production planning, material planning, transportation planning? Is it because, as you showed, Joakim, it's very complex, you need a lot of data, and as you showed, Eric, when you still have adapted the thinking and the thoughts, it's still a lot of things to get in place, and it's like, you know, pulling one ant out of the myrstack, whatever that is in English. Why is it like this?
Well, maybe I could start. At least the experience I have from the companies we've been working with in research projects is that there seems to be rarely someone that really has a good overview of all the parts. There are usually a lot of different people, different functions. Everybody are doing their best, but it's sort of no one has a really good overview. Sometimes even if you have bigger companies, that there is no really good overview of the manufacturing part. So people are working hard to trying to set up different parts of the flow, but still, even if there's a master planning unit, etc., for the actual design of the flow, it seems like it's a kind of issue that everybody is working on a bit ad hoc in different parts of the company, doing their best, of course. But then in some companies, you can see that they're trying to take a more holistic approach to actually looking at the whole flow. But it seems to be challenging. And one problem could be what you mentioned at the start also, that we're sort of drowning in details. And instead of taking a few steps back and looking at what are really the key points here from an overall perspective, and then based on that, start designing the details of it. I'm not sure, Eric, maybe you have a different perspective. But maybe also my impression was that I talked maybe about why you would do different things. And you explain a lot about how this can be done and what is done meant such an idea. But there's always this idea about why do we do different things?
Yeah. I think to some extent, yeah, transport network modeling is not, or the transport network management is not necessarily something that is done very scientifically. Also, so there's, I don't know if there's very often a very scientific approach. So maybe it's because the sites were there. I've always been there historically, or but there's not necessarily this methodical approach to designing a network, and sometimes that can be down to just to the lack of tools, or the lack of the necessary resources internally to run those studies. So that's also the good thing here with LNM, that if you have OTM, that it's easy to run those studies, but without LNM, you have to have different software, different sets of competence, which are not always present, and companies do not necessarily always take the time, because it does take time to conduct those studies. Whereas over here, with having LNM, if you already have OTM, then everything is basically available there. It's very easy. And if you don't, then LNM also makes it, and the approach we've taken makes it relatively easy to conduct those studies. So it's a turnkey solution, really. Whereas if you don't have that, maybe you just don't know where to start.
I guess I also have the impression that there's a lot of effort put into actually modeling as is scenarios. How is it today? And maybe now also there's a shift going on that we start discussing more about what would we like it to be, actually, to model future scenarios. And then you showed some examples of that, where you can actually test different scenarios and how it would impact. But to do that on something that also impacts maybe manufacturing, final customer delivery service, suppliers, there's a huge model to capture all that. So we probably need to find ways of capturing the key control points and the key data to have a reasonably complex model to look at. But maybe there's something out there I don't know, but that's at least my impression.
Thank you, Joakim and Eric. Thank you for your presentations. Thank you all participants for listening. And if I conclude that supply chain network modeling gives you the ability to look ahead, to do what ifs. However, there are some called it challenges on the way, and that is the organization, which could be very complex, which makes it very, very difficult to understand the big picture, and people, they are working more ad hoc, short term. And then, as you mentioned, Eric, there might be a lack of tools available or resources available, which when you have decided to go for it, it might be a little bit challenging.
Well,
okay, thank you all, and have a fantastic day. Cheers.
Thank you.
Bye-bye all.
Bye. Bye.
Bye.